Hello and welcome. This is Milestone 3 for GPE340. Just going to go straight down the list. Apparently the last video I uploaded did not have sound. Character animations imported, character movement, camera tracks player, player has UI health, takes damage, and is destroyed on death. Okay. Camera tracks player, player movement by root motion. And there's the bad guy picking up the gun. Oop, nope, wrong page. Alright, nav mesh built correctly, so let's go to the navigation tab. So the nav mesh is built correctly because even though these are movable objects, it avoids trying to navigate through them because they have rigid bodies and colliders on them. And as we can see, we have the jump off points. And here's the drop distance. So if the AI was walking up here and they decided to jump off, they could. Or if they were up on top here picking up a power-up, they could also jump off the edge here. Alright, so there's the nav mesh. And as you can see outside of the walls, aside from the collidable walls, all of the terrain on the map has an nav mesh. Enemy navigates to player. Well, you just saw that. Show in-game that animations play. Okay, yeah. Saw that. Enemy equips weapon. Not only does enemy equip weapon, enemy also actually seeks out said weapon to equip it. I'll show that again real quick. So, this time I'll take that one. And I'll pick that up. Except of course it seems enemy also hits themselves with said rifle. And enemy ragdolls. Cool. Using reverse kinematics and different shot types. Okay, show code. Show in code that weapon and player use the same weapon code. Okay. Well, we pick up the same gun, so by default that requires that we're using the same weapon code because we're using the same game item. Open the ragdoll and explain how it works. Show in game and in code enemies can toggle between ragdoll and animated modes. Show and explain code that causes enemy to ragdoll in death and after a delay be destroyed. Okay. Alrighty, so enemy spawn over time. Alright, well, let's just show this one repeatedly. I'm just going to spawn camp the bad guy. Respawns. I kill it. respawns again, kill him again. Alright, enemy spawn points are shown using the gizmos and editor. Okay, so there's the video on all the gameplay. I still have some kinks to work out when it comes to dealing with the bullets and telling things not to look for an animator that's been disabled because of the on-death stuff. But, okay. Let's go to here. Yeah. So, as we can see here, off the basis of the hips, we actually have the full rigid body collider for the wonderful, fantastical ragdoll. And what we have with this one is when ragdoll's enabled, it just falls limp on the ground and shouldn't fall through the ground because of ragdoll. So we have the rigid body. This is the base rigid body for the entire construct when it's running. It's the one that's on when the ragdoll colliders and rigid bodies aren't. Here's the nav mesh agent that we use. The speed actually gets overridden. The nav mesh, the components for the nav mesh. Here's the ragdoll collider. Since this is the absolute parent object for all the ragdoll colliders, this actually gets passed into the ragdoll collider control script in order to pull all of the child colliders and rigid bodies off of it for the use in the ragdoll. As you can see at the start, there is actually nothing in the ragdoll rigid bodies and ragdoll colliders. So for the sake of argument, I'll actually just go over here, start this long enough to spawn an instance of the bad guy. Okay, so now we've spawned an instance of the bad guy. So we'll go into it. And now when we take a peek at the ragdoll colliders, since they've actually started, we can actually see in the array, which is why I made it a serialized array, all of the various rigid bodies and capsule colliders have now populated the list. Didn't necessarily need to do it that way, it's just really convenient for me as a programmer to just program it out. Let's go ahead and continue. Oh, I just ended the scene. Not what I wanted. There we go. Alright, now to show more bad guy knowledge. Huzzah, bad guy knowledge. So, just like previously when we were seeing the rigid body colliders and everything else, which occur as soon as the ragdoll script is executed on startup, we can also see the AI controller script here. And we can see its weapon target is Sci-Fi Rifle 1, which it's currently heading towards. And if we go up here to the nav mesh agent, somewhere, yeah, there it is. You can't see the destination set for where it's going. Which is interesting, but it's neither here nor there. So the weapon target is what it's currently going at. You can actually see that it's pointing itself at the Sci-Fi Rifle 1, and that its current AI state of the finite state machine is look for gun. So what it's doing is it's going to go over there and pick up the gun. And now that it's picked up the gun, you can see here that the equipped weapon has changed to Sci-Fi Rifle 1 weapon class, and yeah. So now you can see, well, its AI is still set to look for gun. And now it's set to look at player, or shoot at player. Yikes. Right now, I'm throwing up a lot of bugs because I've been running this as long as I have. There's all the various sounds where it was stepping. That's kind of cool because then you can actually use like a motion Doppler effect in order to track where something stepped. Which can be really cool if you want to do a kind of like alien style motion tracker. But let's go ahead and end that. So, now first off, animations still exist, yes. The animations obviously still exist. There's the animation set for the Vanguard. If I click on player pawn, we can see the blend tree for the player pawn, which is massive. Nav mesh built correctly, yes. Enemy uses root motion, so here we go. Well, actually, you just have to go to this guy. Open the prefab, apply root motion. Check. And enemy uses root motion, so let's go ahead and dive straight into the code for that one. Enemy uses root motion. So here's the main thing in order to demonstrate that it uses root motion is by passing the desires of this pawn director. This pawn director, if we come up here, is the nav mesh agent, and we have the nav mesh agent passing instructions to the make movement. And then it is the inverse transforms and everything else in order to make everything line up with the animator. Because then it passes it to this animator, and this animator is somewhere up here. But it passes it up back to this animate, and this animate is the animator that I think is actually a part of controller. But that's not really material. It just passes it back up to the animator, and then the animator goes ahead and animates the movements of the pawn. Shoots at the player. Well, we already saw it's more than capable of shooting at the player and shooting itself in the foot, which is funny. I just need to decrease the size of the collider in order to avoid that. But, yeah, the shooting script is really simple right now, because there will be some later updates to it, and that's shoot at player here. I'm going to do raycast later on so it doesn't try shooting through walls, because that gets strange. But what it does is it checks there's two method variables that are bools that it checks in order to determine if it's aimed towards someone, and the base.pawn.turn towards is just to make certain that the pawn turns towards where the player is before shooting at them. Nothing really fancy. And it only enters into any of this logic if the player target, which is the location of the nearest player at the time of the AI update, is not null. And then if all this is true, it goes ahead and shoots. And while it's shooting, it goes ahead and it also stops the movement for the nav mesh agent. But that's pretty much it. So it shoots a player, enemy equips weapon. show in code that weapons and that the okay, I think that's supposed to be that the enemy and the player use same weapon code. Okay, so that's pretty simple. You can see that they pick up, that the player and the AI agent pick up the same guns. The AI agent is capable of finding, tracking, and picking up the guns on the map. Show and explain inheritance and polymorphism of the weapons class. Okay, so for the base class we have weapon, which is just the IK stuff. The IK points on the gun, what type of gun it is, the various unity events for starting an attack, stopping the attack, and when it attacks and when it stops. And that gets inherited by weapon class, which is on the weapons themselves. If we go up here, you can see weapon class inherits from weapon. And this is all the additional stuff that weapon class inherits from weapon. This is what happens when it picks up ammo. This is how it enables or disables the pickup. And this is how it equips. So you have the one method for the player because it attaches in a different fashion, then you have the other method for the bad guy and how it attaches to him. So you can see the fact that they both use the same collision entry, they just use different executions of an if statement inside of it. And it was set up this way so that I couldn't just like put an else here, because this checks for all collisions with the box on the weapon. Okay. And equip weapon, enemy ragdoll and death. Okay, let's just go over the ragdoll container real quick. Ragdoll container contains an animator, it contains this hip set, it contains these ragdoll rigid bodies. These are both the empty arrays that are started off. I just pull all the children for that are based off the hip set, which is the starting point of the animation rig, and load them into the two arrays, as you can see down here. And then I tell it deactivate ragdoll. So down here it makes it so that all the rigid bodies for the main stuff are true and are not kinematic, and that the animator is true. And then for the AI, the main difference between the AI and this only triggers, I use the same script for both the player and the AI. This only triggers if the AI is true, and it goes ahead and enables the NavMesh agent aspect, as you can see right there. NavMesh agent, this NavMesh controller. So that is the controller that makes it move around on the map and do its pathfinding. And then, as you can see down here, it does it for each of this rigid part in these ragdoll rigid bodies. It goes ahead and makes them all kinematic, and then down here for each collider in this collider part of these ragdoll colliders, it goes ahead and disables them by turning its enable public member into false. Then the activate ragdoll just does the inverse of that for everything. It disables the main body collider, it makes the main rigid body kinematic, and it makes the animator false. And then everything it does over here is it just goes ahead and does the check for the AI again, and neither disables or enables the NavMesh controller, or the NavMesh agent, really. And then it just turns all of the rigid parts that are a part of the ragdoll to not being kinematic, and it enables all the colliders for all the ragdoll bits. Okay, enemy spawn over time. Bad guy spawner. The bad guy spawner just spawns them on the basis of the respawn cooldown here, and the cooldown time, what the current countdown time is for the cooldown. It only enters activity when the bad guy out control, which is the container for the instance of the bad guy being spawned. When that is null, then it enters into this logic. If the cooldown timer doesn't exceed the minimum respawn timer, then it sends it down here and increments the cooldown timer on time.delta time. And once it goes ahead and gets larger than the respawn cooldown, it goes ahead and triggers the create baddie and resets the cooldown timer. So that's really straightforward. Okay, so AI controller. For the AI controller, scroll more back up towards the top, where we'll be at the bottom of our switch statement. So this controls the movement, which we covered before, and this is how it applies the root motion, because it's applying the root motion to the animator in order to get the character to move. But the main additional feature that I have for mine is the fact that I actually implemented a complete finite state machine for my AI controller, and it mainly consists of two things. It consists predominantly of the update AI behavior, and then it consists of the switch statement, which controls the execution of the logic. So the update AI behavior is the set of nesting if statements that produce the Boolean values which determine which AI state it's currently going to be in, and then the switch statement inside of the update method for the AI controller actually executes those AI conditions and checks the relevancy of checks the continued relevancy of their execution. So if the pickup target gets destroyed or gets deleted or is no longer valid, it switches it to nothing, and then it goes ahead and it will push back and attempt to update the behavior again. So there's only really two parts to the timer for the AI, and one of them is the secondary timer, how long it's going to stay in a state of AI execution before it attempts to look for a different state if it can't accomplish the previous one. And then the second one is going to be how long it will wait without something before it goes ahead and runs another update for the AI behavior. Then, as you can see, depending on what the current AI state is, it breaks out through one of these methods. And the only thing that like reach ammo, reach for gun, reach for health do, and it's very easy to show, is it just sets a different destination and changes the stopping distance sometimes. So when it's going for the pickups like a gun, a health, or ammo, it changes the stopping distance to 0. But when it's going after the player with the chase player here, as you can see, I use mathf.clamp to make sure it can't dip below the value of 0, because the distance that a vector has in relation to something else must always be positive as a positive existence, because the value of the distance must always be greater than or equal to 0. So either 0 right on top of it or greater than 0 in some fashion. That's pretty much it for that. But for the AI logic, it's really simple, and most of them reuse this. This is just a very simple what's closest to me algorithm. And what that does is it just gets a null game object, and it goes ahead and backfills that with information from other points. It will attempt to find every object with the tag. So for found weapon, it will attempt to find every object with the tag find game objects with tag weapon and load them all into an array. And then the for each will just iterate through all the items in the array, looking for the one that's closest, and then it just loads that up as the target. So weapon target is at the top, it loads the closest one up into the top. So every time it finds a gun, it'll actually print this line in the debug, and it'll load the closest one it found up into weapon target and return true. If there are no guns, it returns false and it stops looking for a gun, because that's a lot more efficient than having it spin around in circles trying to find something that doesn't exist or looking for a null value. And pretty much everything I have with it that is trying to find a pickup or an equipment or anything else is all contained within that logic. Alrighty, so the finite state machine, the fully implemented finite state machine with the pickup capability for the AI, so it can actually pick up health and ammo as well as the gun when the criteria are met. So, like when the logic for needs health, which is when the current HP is half, then is less than half of the maximum health, it will look for health. And if it needs ammo, it will go ahead and look for ammo. So when the current equipped weapon's ammo is less than or equal to 40, it will search for ammo. One of the unique things is that if it can't find an ammo pickup, is that it will actually just search for a new gun, because all the guns that drop contain ammo. So if it can't find an ammo pickup to replenish the stock of the gun that it already has, it will actually seek out a new firearm, which is different. But that's pretty much it. It doesn't really seem that significant, but it took quite a few hours to program. So for the serialized field for the gizmo spawner, the gizmo spawner is just a real nice feature for a designer to be able to go through and as a programmer mark stuff up so that they can more readily see it and more easily interact with it, because having the gizmo means that when we go to our scene, we can actually see where the spawner is without having to click on it. And even if we do click on it, it's much easier to manipulate now, and it's much easier to tell where it is. So, like say I wanted to extend the ray out, because right now it's at 0.4 float. If I wanted to extend that out to like 6 or 12 in order to model a trap of where it's going to be, where it's coming from, I would just have to extend this out, and I could use a bunch of different colors to indicate the color. In fact, I could probably use the color dot enumeration, whatever type it is that's from Gizmo, in order to have a drop-down choice to change what the color of the box is. And the design for everything makes it a lot easier to implement and see and deal with than if I was just to use like a regular straight-up empty. Which makes life easier for designers. So enemy navigates to player, enemy uses root motion, enemy shoots at player, enemy equips weapon, enemy ragdoll on death, enemy spawn over time, enemy spawn points using Gizmo and editor. Yeah. So why I feel my code is very well scaled and well commented is very well commented on most of the stuff, especially here, and then the AI controller. Scope-wise, almost everything I put in is of the private type, and if I need it to be visible in the inspector, I put serialize on it. And the main reason for doing that is so that when I put serialize on it, you can see it from the inspector. So even though these don't get assigned through the inspector, you can see them in the inspector for troubleshooting purposes. Weapon class, as you can see, clearly see here, it just allows the player and the bad guy to both pick up the same weapon without any problem. But yeah, other than that, that covers everything. Thank you for your time.